Okay, our core functions are coming now, and the negative angles to add to our reduction angle formula that we learned a lesson ago. So what we want to do is to add that 90 and 270. If you remember, I said on our Cartesian plane we have 0 here, 90 there, 180 here, 270 over there. So these are the things that we said we had. And we used our cast diagram like this, and we named these ones our quadrants. So we know this already. We know how to use 180 and 360 to simplify our angles. So in this situation, I want us to learn how to use 90 and 270 to also do the same, to simplify. So the thing is, while we were using 180 and 360, we were maintaining the same function. What I mean is, if we had sine 180 minus theta, we knew this was the second quadrant, and we changed it to sine theta. As you can see, it's sine function here, and it's still the sine function over there. It's not the same with the core functions now. So the core functions change the original function to its core function. So the core ratios, or whatever it is that you name them. So let me take, for example, why don't I say sine 90 minus theta? I'm using 90. Well, the same applies. That whole process of finding which quadrant we are in still applies here. So I'm going to ask you to appreciate how this is in the first quadrant. So an angle called 90 minus theta would definitely be in the first quadrant. In the first quadrant, luckily for us, everything is positive. Rather, those three functions that we deal with, tan, sine, and cos. So here it is. If it wasn't 90 here, this was just going to change to sine theta. Okay, it's making me itch a little to write that incorrect thing there. So that is what we were doing. If this was perhaps 180 here, we know that it was going to just change to sine theta. But this is 90 degrees. It changes it to its core function. So please notice the core functions we're going to deal with are sine. Its core function is cosine. So the others, there is tangent and the cotangent. We are not going to use that one. So we just use sine and cos. So this one we change to positive cos theta. Instead of writing positive sine theta, you write positive the core function, which is cos. Let's see if you get it. If I have sine 90 plus theta, the first thing I'll do is I figure out the quadrant. And the quadrant here is actually the second quadrant. So the angle will be right there. That's the second quadrant. And again, sine is positive here. So instead of me writing sine theta here, I'll write positive the core function of sine, which is cosine. I still want to see if you're getting it. So what if it was cos? Like that. Again, you figure out the quadrant first. Cosine is positive there. And since it's positive, we were going to get positive cos theta, but because of the 90 degrees, we write it as positive sine theta, because the core function of cos is sine. Let's go. What if it was cos 90 plus theta? Now you're noticing it's the second quadrant, and in the second quadrant, cosine is negative. So you know it's negative, but you're not going to write negative cos theta because of the 90. You write negative sine theta. So this is what you do. So these are core functions. This is how they work. Just so you can have more fun, let me put the ones for 270 degrees, although we don't use these ones much, but we're going to just have them. So let's see if you can get them fast. I'm going to just do this, and most of you are seeing how 270 minus theta will be an angle in this quadrant, the third quadrant. So in the third quadrant, sine itself is negative, so it will change to negative cos theta. So I can carry on and put as many things as I want, as long as I have 270 there. Third quadrant, isn't it? 270 plus theta. Rather, fourth quadrant. And in the fourth quadrant, sine is negative, so it changes again to negative cos. So this is how we will be finding them out as we go. You know, I may just leave one, and that's where you get confused. Third quadrant, cos is negative. Are you seeing how it is negative? The cosine will be negative in the third quadrant, and therefore we write this as minus sine theta. It doesn't harm us to just write that one too. And since it's over there, fourth quadrant, and we're dealing with cosine. In the fourth quadrant, cosine is positive, as we remember. So since cosine is positive, it will change to positive sine theta as well. So these are the cofunctions, and this is how we find them. We don't even memorize anything. We just really think about it when the situation arises, as long as you know how to get your quadrants. And remember, if it is 90 or 270, the function will change to its cofunction. That's the difference, the main difference between the cofunctions and the way we use reduction, 180 and 360. It's very simple, really. So since life is getting simpler like this, I'm just going to give you this. This I'll just let you know. We will find a good day to explain this one using the Cartesian plane. So there are identities I want you to have in your head. Keep these in mind. This is very important. It's the only main reason. We call these ones negative angles. So I'll show you how we deduce these ones. But for now, just notice how we have them. Appreciate the fact that we have such things in trigonometry. Here, it's minus tan A. So we're on negative angles. What I want you to see is that if it is sine negative A, it'll be negative sine A. And the same happens with tan, the negative comes out. But for cosine, that's the only outstanding thing, it's the same. So if you go and say cos minus 60, you'll get a half. And if you say cos 60, you'll still get a half. So these are the things you must know. I'll show you using your x and r on your Cartesian plane how these are the ones. But for the sake of this lesson, we just use them as the identities we know, the negative angles, on top of our cofunctions and our reduction angle formula. So I want you to bring everything you know on board so we can answer these questions now. So absorb that quickly, because now I'm going to show you the type of questions they ask, where you apply everything you know to get to what you want. So we can only do so many, but let's try to have as many as possible. Let's have the first one quickly. I'm going to start with this one. So let's say we have tan 180 minus x, sine 360 minus x, then cos 90 minus x. It is really everything coming. Okay. Well, I finished copying that one down. I made that one up. Right. Having that one, this one actually is from your exercise. You will see it quickly when you do your exercise there. So here is what we have. This has got the right number of terms, and you can reduce this one and get to what you want easily. I think the only new things are this one and that one. So you just have to be careful with that 90 degrees. Everything else is the same. So I'm not going to assume that this one is difficult for you. So let's get used to the fact that, let me draw it maybe, cast. Not that we need it, but maybe some of you still need to see this. Let's just see. 180 minus. 180 minus, I think you now know this is the second quadrant, and in the second quadrant tan is negative. I'm going to do this fast. It doesn't, you get this now. This one is the fourth quadrant, and this is negative as well. And now 90 degrees. Firstly, it will change to sign. But is it going to be positive or negative? So since this is the first quadrant, you know, this is the fourth quadrant, the first quadrant, third quadrant, second quadrant, and third quadrant. So since this is in the first quadrant, everything is positive. So this will change to positive sine x. Third quadrant, and in the third quadrant, sine is negative 90. I think you're noticing there's 90 here, and since it's 90, it will changes to its cofunction, which is sine, and because in the second quadrant cosine is negative, it will change it to minus sine x. Please pick that up, because cosine is negative in the second quadrant. When it changes, it will be negative. Instead of negative cos, it will be negative sine because of 90. Alright, that one will become positive tan x. We all know that one. So the first question is always simple. So notice how those two will cancel. Let's cancel that. The negative is remaining. Watch out for that one. We didn't cancel the negative. Here even the negatives cancelled as well. Oh, there is this one. The negative remains. So we have these two negative signs left. So negative, negative, it will become positive. So we're going to get 1 as our final answer there. It should be simple to see. Absorb that one as I copy the second one down. Life can get very tricky. There is another way they trick you, and I'm thinking this will be the best question to actually show you how you can easily be tricked. I've seen people falling for this one, so for this type of sums. So I'm hoping you understand this second one we are putting on the board now. Then there's cos of negative b sine of 360 plus b. Okay, something of that sort. Well, in this situation, the only problem is, you know, the angle we want, the acute angle that we think of, is the one that's starting the angle beta minus 180. It wasn't going to be a problem if you say 180 minus beta. It's not a big issue. And here, look at how they are arranged. This is what we've been doing so far. These are negative angles, but these two, you have to work carefully with them. And this is the method I will suggest you use. Let me actually show it to you properly. I want you to do it this way because I found it's actually faster than factorizing. So if you remember, I said if we go in the positive direction, it will have to be in the anti-clockwise direction, like 0, 90, 180, 270, 360. But for negative angles, you have to have 0 here. This will be negative 90. If I go this way, I'm going in the negative. Negative 180, negative 270, and negative 360 will be here. I went clockwise. Well, our cast doesn't change. It's still C here, it's still A there, it's still S, it's still T. How we label the quadrants doesn't change as well. But the way I labeled my Cartesian plane, I am anticipating negative angles, so I put it like that. So it should happen fast in your head. Now, how does this help? Well, when we get to this one, especially if it starts with beta, well, there is a factorizing method that you can use as well. But at this point, I want you to use, wherever there is beta, I want you to put, say, 10 degrees, an acute angle. So in your mind, work with 10 degrees over there. So if you say 10 minus 180, you should be able to get minus 170. and then you go and find where minus 170 is in this. So minus 170 will be here in this quadrant. You can see. So minus 170 will be in the third quadrant. So this angle here is in the third quadrant. So beta minus 180 is an angle in the third quadrant. So since it's in the third quadrant, sine is negative. You'll be able to do it fast if you're used to doing many sums, right? Again, have 10 degrees in place of beta in your head. You have minus 10 minus 180. So this will be like minus 190 that you keep in your mind. So you go and find minus 190 here on this Cartesian plane, and minus 190 would definitely be in the second quadrant. Now that we have agreed that minus beta minus 180 is an angle in the second quadrant, now we ask ourselves, in the second quadrant, is tan positive or negative? And yes, that's how we figure out it's negative. So we put it there. That is all, and it's a very good method to use for the tricky sums that will come your way. So make sure you use it with going negative and in the positive whenever it's required. And the more you practice, the faster you get with that one. Well, this is the usual one, 180 plus. This is third quadrant, and cos is negative. That's our usual guy right there. No need to stress. And from the negative angle identities, you would remember the negative sign just simply vanishes. And that will be cos beta over there. Let's finish this one. 360 plus, this is our angle in the first quadrant, so it will be sine beta over there. Should be very simple to see. Well, if you can handle this type of sums, then you can be sure not to get tricked in any way. Well, let's see what cancels here. If there is anything that cancels, we want to cancel it fast. The signs, the negative signs, make sure you work with them well. So this negative, we change that one into a positive, rather. Let's change this one into a positive. Negative times negative, positive. This positive and that positive will cancel. It means this guy is left alone. So it does look like minus tan beta is left here. It's no use changing it to sine beta over cos beta because it's not going to cancel with anything. So you can leave it here as one term, at least. Then it will be simple right there. Okay, good. Let's keep going. Let's keep having a few more examples to get this in our heads. Copy that one as I answer this one with you. Let's add. Let's call it number 3. Well, this was interesting to look at, so I just thought, why not? Well, let's just do it, since it has our cofunctions in it. Let us have cos 90 minus x over here, and I'm going to rather have plus cos minus x on the other side. This is negative x here, negative x. Hope you'll be able to see it's negative x on the other side there. Well, it's very different from what we used to. We're used to fractions and going like that. So those two brackets are multiplying, and I thought it would just be good to look at them. So why don't we do that one together as well? Let's see what's what. So you can see, let's simplify what you know. So this part you know very well. I don't have to keep asking you. You know it's second quadrant and it's positive sine x. 90 degrees. I think you're getting used to this now. It changes this to its cofunction, which will be positive cos x because this is quadrant 1. Okay, the square brackets, I'm changing them to this. Then this one again is in the first quadrant. It will change that one to positive sine x. And since these are negative angles, cos of minus x is the same as just saying cos x, right? So you have this one, and it's like you have this squared, so it should be easy for you to see. Let's simplify it. Sine x times sine x will be well known to be sine squared x. This times that, that's sine x cos x. And this times that will be another sine x cos x. So I'll just write it like this. And then that one, multiplying those two, you get cos squared x. If you FOIL, you also get the same one. But do you remember the identity I taught you before in our very first lesson? That one plus that one is an identity equal to 1. So please keep that in mind. Sine squared x plus cos squared x is actually just 1. Plus 2 sine x cos x. If you were in grade 12, I was going to say sine 2x here, but for us, we stop right there. That's enough for a grade 11 child. So, good for us right there. Let's have another one. Let's keep going. I want you to get used to your core ratios as well as other things. So this will help you a lot. Let me put the sum now. The sum here, sine 360 plus theta, let's put it there, sine of negative theta. Okay, looks pretty enough to me. It should be easy to handle as well. Your core functions here, and perhaps you want to be careful with that one, and your negative angles here, everything else is fine. So make sure that you remember everything. So let's see if you can follow here. This squared means cos 90 minus theta and everything squared. It's practically this. I told you before that we don't do that. We prefer putting the squared over here. So what you do is you change this one, which is going to change to sine theta. So this is the same as saying sine theta, and you square it. So the reason I want you to not worry much about things that are squared, imagine if it was plus. It was going to be minus sine theta. But again, when you square it, it was simply going to go back to positive sine squared theta. So these ones, when there's a squared, it's always an easy one to handle, because you know that it doesn't matter which quadrant, it will eventually be positive anyway. So at this point, let's do it and write it as sine squared theta. You know why? The 90 changes cos to sine. And this is the type, since they are seemingly negative in every way, you put your 10 degrees there, minus 180 minus 10, that will be, say, negative 190. Negative 190, we know that it will be in this quadrant, because this is where your negative 270 will be. So second quadrant, cosine is negative. Another way of doing that is perhaps to factorize the negative out. And if you factorize it out, there will be 180 plus theta left, and this negative, it will go away using the negative angles. It will cancel, so you'll only be left with cos 180 plus theta, which will also give you negative cos theta. But this diagram will work better for you, I guess. Okay, fourth quadrant, simple. Fourth quadrant, tan is negative. Negative tan theta right there. And this, I don't have to talk about it much, it's the first quadrant, so that one we get it fast. Negative angles now. Negative angles are simple again. You just have to remember, for sine, you take the negative out. So here you can really get rewarded for having a good memory stick in your head. Okay, good. So this cancels. Notice my negative remains. So negative divided by negative, let's make cos theta positive. So I have positive cos theta here, and this is minus tan theta. I'm going to change it to minus sine theta over cos theta. You know this now. And let's see. Isn't that beautiful when we cancel that out? So our final solution for this one will be negative sine theta right there. So that is our final answer for that one. Let's have number 5. Usually let's have number 5, and that's the last one, and it will be introducing the next lesson. So how else can they ask you to simplify this one? Let me put number 5 on the board, and then you can do a lot of sums first and then ask me. Then I will send a few more videos to you that explain your exercises. So here, let's have this one, so you can be ready for your next lesson. Now there are numbers. There are numbers involved, real numbers. Now, all you have to remember are your special angles. I hope you remember them. 30 degrees, 45 degrees, 60 degrees, 90 degrees, all of those ones, we use those ones a lot. So those are the ones that will be required here for you to remember to simplify this one. So instead of just working with an angle which you are calling 180 minus theta and you don't know what theta is, in this one you'll be working with the angle that you see. So they may ask you to, without using a calculator, to handle this one, to evaluate this one without a calculator. So how do you do this one? Of course, you change them to the special angles that we mentioned. We know already those special angles. In fact, your calculator knows all of them, except you have to be careful with tan 30. Your calculator will give you as root 3 over 3, and you are expected to remember it as that. Then sine 45 and cos 45 as well. You have to be careful there. You are to remember it as 1 over root 2 and 1 over root 2. Is there another one that you need? I should think that everything else, your calculator gives it to you properly. You can use it to get them, but your triangles work better. And those triangles, you already have them. So please just keep these ones in mind. Okay. Now, what do we have here? 120. So you ask yourself, which special angle is close to 120? And I know most of you are saying 90 degrees right now, but we do our best to avoid 90 and 270 actually, for the reasons you know. In case you forget to change the function to its cofunction, you don't want to put yourself in a place where you can easily lose marks. So for this one, if you can also write it with 180, you can do that. So this is 60 degrees away from 180. So you can see this one as that. It works better that way. And then this one is close to 360. So I'm going to say it is 30 degrees away from 360. This is how we handle this one. But we have a full-on lesson with all of these, but this is a very good introduction. I'm going to avoid 90 and use 180. They are equally far away from 135. So this will be minus 45. Notice if you say 180 minus 45, you should get back to here. And if you do this, you should get back to there, something of that sort. Okay, 225, I can also use 180. Reduction angle formula are easier than cofunctions. They are both easy, but that one is easier. So this one will be plus 45, like that. So you change the expression you have to something you can handle. So you can have small angles that are also special, right? So in this situation, let me change this one. This is now the second quadrant, and in the second quadrant, sine is positive. And and 360 minus is the fourth quadrant, and tan is negative. But the good part is it's squared. Since it's squared, the negative will cancel. So it will be minus tan 30 times minus tan 30. So it will be positive tan squared 30 anyway. So a square is a good thing. Right? Second quadrant, cosine is negative. Third quadrant, sine is negative again. Alright, so this should work. Now these are special angles. Your calculator can give you these answers easily, but you'll be solving something that is without using a calculator, so we see what's what here. Sine 60 should be root 3 over 2, and tan 30, it's the one I said you must remember. So it's 1 over root 3. Forget it's squared over there. And then these little guys here are also something you should remember as well. You use your triangles if remembering these is a problem. So whichever way you do it, it doesn't matter. Your triangles or your whole revolution, whichever way you're doing it, I do not have a problem at all. So I'm going to simplify this without a calculator just so I can give you an example. 1 and that 1 squared is just 3, and here this will become positive half. So this is root 3 over 6 multiplied by 2 over 1. 2 will cancel there, 3. So it'll be root 3 over 3. So you will have a lot of these to solve as well, this type. We still need more sums on these, but for this lesson, this is just about it. So you can do a lot of exercises after these 2 lessons. So make sure you do them. Thank you very much.